The universe is vast. We look up at the night sky, a sea of stars, and grapple with a profound question. Does it ever end? The idea of an infinite universe, while captivating, presents a paradox. How can something be both boundless and contain everything? This is where the McGinty Equation, or MeQ, comes in. It offers a new perspective, a way to reconcile the seemingly contradictory notions of finiteness and infinity. Imagine a universe that's like a fractal, a pattern repeating infinitely, yet contained within a defined structure. The MEQ attempts to untangle this cosmic knot by drawing upon cutting-edge physics. It blends quantum field theory with fractal geometry. Imagine the universe not as an expanding balloon but as a growing fractal, its patterns echoing into infinity. This framework allows the MEQ to address the paradox head-on. It proposes that the universe can be both finite, in terms of what we can observe, and infinite in its overall structure. The MEQ provides testable predictions. It suggests that we might find evidence of the universe's true nature by studying the cosmic microwave background radiation. Imagine finding repeating patterns in this ancient light, a cosmic fingerprint hinting at the universe's fractal nature. This is the power of the MEQ. It bridges the gap between abstract theory and observable reality. Join us as we explore the MEQ, a journey to the edge of understanding, a quest to solve the infinite puzzle. The McGinty equation turns to an intriguing branch of mathematics fractal geometry. Imagine a coastline, its rugged edges twisting and turning. Zoom in closer and you'll notice that the smaller inlets and outcrops resemble the larger shape of the coastline itself. This is the essence of a fractal self-similarity across scales. The MEQ proposes that the universe might behave in a similar manner. Just as a tree branches out, with each branch mirroring the structure of the whole, the MEQ suggests that the universe might be composed of nested, self-similar structures. Imagine our observable universe as just one branch on an unimaginably vast cosmic tree. Each branch, while finite in itself, contributes to the infinite expanse of the entire structure. This fractal framework provides a crucial insight into reconciling finiteness and infinity. If the universe is a fractal, then it can be both finite at any given scale and infinitely vast when considering its overall structure. The MEQ proposes that this fractal nature is woven into the very fabric of space-time. This intricate dance between finiteness and infinity has profound implications for our understanding of the universe's fundamental nature. The concept of local finiteness within a globally infinite structure is key to the MEQ's resolution of the universe paradox. Think of a single snowflake. It's finite, with a defined shape and size. Now picture a blizzard, an endless flurry of snowflakes. Each snowflake remains finite, yet collectively they create an experience of vastness, a seemingly infinite expanse of white. Similarly, the MEQ proposes that our observable universe, with its billions of galaxies, is akin to a single snowflake in a cosmic blizzard. It's finite and measurable, bound by the distance light has had to travel since the Big Bang. However, this observable universe is just one of countless other snowflakes within a potentially infinite cosmic expanse. This perspective challenges our intuitive understanding of boundaries. In a fractal universe, there's no need for a hard edge, a wall at the end of space. Instead, imagine traversing the universe, moving from one snowflake to another, each transition seamless, each new region as vast and complex as the last. The MEQ suggests that this journey could continue infinitely, a testament to the universe's boundless nature. The fractal nature proposed by the MEQ has profound implications for how we perceive the universe's structure. Imagine a tapestry woven with intricate patterns. Up close, each thread, each color variation stands out, creating a sense of individual elements. But step back, and the individual threads blend, revealing a larger, unified design. Similarly, the MEQ suggests that the apparent separation between galaxies, clusters, and even larger cosmic structures might be an illusion of scale. What we perceive as vast cosmic voids might be, at a grander scale, simply the spaces between the repeating patterns of the fractal. Just as the threads in a tapestry are interconnected, these seemingly separate cosmic structures could be woven together within the fabric of a unified fractal universe. This interconnectedness challenges our notions of distance and isolation. If the universe is a fractal, then every point in space, every galaxy, every star could be ultimately connected through the intricate web of the fractal structure. Imagine a cosmic web, its threads tracing the paths of energy and information, linking the most distant corners of the cosmos. The MEQ suggests that this web is not merely an analogy, but a fundamental aspect of the universe's architecture. This shift in perspective from separation to interconnectedness has profound philosophical implications. The universe's edge isn't spatial but temporal. Light's travel time defines our observable universe. Beyond this horizon, countless galaxies remain unseen. The universe is a dynamic, evolving entity. The MEQ redefines the universe's edge, proposing a dynamic fractal spacetime fabric. Imagine spacetime as a dynamic tapestry woven from quantum fluctuations and gravitational interactions. This fractal fabric is key to understanding the MEQ's universe. Spacetime itself possesses fractal properties. The universe's structure might exhibit self-similarity across vast cosmic distances. The MEQ's concept of a temporal edge and a dynamic fractal spacetime reshapes our cosmic perspective. Our universe is just a tiny part of a grander structure. Imagine the horizon marking the limit of your vision. As you walk, new vistas appear, but the horizon remains. Similarly, as time progresses, we uncover new cosmic structures. The temporal edge of the universe always recedes. This realization is humbling and awe-inspiring. We're limited by the speed of light and the cosmos's vastness. The MEQ challenges the notion of a universe center. Every point is both central and insignificant. This perspective undermines any anthropocentric view. The MEQ invites us to embrace a new cosmic perspective. The McGinty Equation challenges a deeply ingrained notion about our universe. The idea of galaxies hurtling through space, propelled by the forces unleashed in the Big Bang. Instead of this traditional view of cosmic expansion, the MEQ proposes a paradigm shift, a reimagining of expansion itself. It asks us to visualize the universe not as an inflating balloon, but as a growing fractal, its expansion driven by the very fabric of space-time. Imagine a piece of paper covered in an intricate network of lines. Now, picture those lines not as static markings, but as dynamic entities, constantly stretching and expanding. The paper itself, representing space-time, also stretches, carrying the lines along with it. This is akin to the MEQ's concept of fractal expansion. It's not just that objects are moving apart within a fixed space, it's that the very fabric of space itself is growing, stretching out the cosmic tapestry. This fractal expansion elegantly addresses one of the most perplexing questions about an infinite universe. How can something infinitely large get even bigger? If the universe is infinite, it already encompasses all of space. However, the MEQ's framework provides an answer. Just as a fractal pattern can grow infinitely more complex without changing its fundamental nature, an infinite universe can continue to expand by increasing the separation between points within its fractal structure. This redefinition of expansion has profound consequences for our understanding of the universe's evolution. The MEQ's concept of fractal expansion paints a picture of a universe in constant flux. Imagine a singularity of infinite density and potential. Picture that point unfurling, revealing layer upon layer of complexity. This is the essence of the MEQ's fractal unfolding. It's governed by the mathematical principles of fractal geometry. The universe's structure arises from fundamental physical laws on space-time. Patterns at the largest scales could be echoes of the universe's initial fractal blueprint. This fractal unfolding has profound implications for our understanding of the universe's origins. The Big Bang might represent a transition point in the universe's eternal unfolding. Imagine a continuously evolving fractal, with the Big Bang marking a dramatic phase transition. The MEQ's fractal unfolding provides a framework for understanding the universe's evolution. The universe is a dynamic, ever-changing entity, its future linked to its fractal past. The MEQ's framework embraces fractal expansion, presenting a universe without boundaries. Imagine a journey through this limitless universe where new regions constantly unfold. Endless possibilities for exploration and discovery. Embrace the grandeur of a cosmos beyond comprehension. The human mind, in its quest for patterns, grapples with infinity. Does this boundless expanse allow for repetition? Could another Earth, another you, exist somewhere in the vast cosmic tapestry? The McGinty Equation suggests repetition might be inherent in the universe's fractal structure. Imagine a vast hall of mirrors, each reflecting the others, creating an illusion of infinite depth. The MEQ proposes that the universe's fractal nature could manifest similar patterns of repetition. This concept raises profound philosophical questions about identity and the uniqueness of our existence. The McGinty Equation explores repetition in an infinite universe through quantum mechanics. Quantum mechanics adds intrigue to cosmic repetition with its uncertainties and probabilistic nature. Imagine the universe as a grand symphony governed by quantum laws. Particles exist as waves of probability determined by chance and observation. This uncertainty shapes the universe's fractal structure. Like a violin note resonating, quantum states manifest in countless variations. Quantum variations lead to distinct realities in different cosmos regions. Imagine two universes born from the same quantum fluctuations. Their fractal structures amplify differences, leading to unique cosmic histories. The MEQ paints a universe teeming with possibilities, a cosmic canvas of endless variation, a multiverse of possibilities, a grand quantum symphony of existence. The McGinty Equation combines fractal geometry and quantum mechanics, suggesting repetition in an infinite universe. In a boundless universe, similar patterns are statistically probable. Imagine flipping a coin infinitely. Probability ensures sequences of heads and tails. Similarly, the MEQ suggests matter and energy arrangements repeat in an infinite universe. These repetitions are variations on a theme. There might be Earth-like planets with similar life forms. This challenges our uniqueness in the universe. It opens up exciting possibilities. The universe is a stage for countless dramas. The MEQ offers a framework for understanding repetition. Our universe is one story in an infinite library. Imagine an ant living on the surface of a perfectly smooth sphere. From its perspective, the world is flat, extending infinitely in all directions. Yet its world is finite, bound by the sphere's surface. This is the essence of a hypersphere, a concept that explores the potential shape of our universe. Our three-dimensional universe might be curved, forming a four-dimensional hypersphere. This curvature arises from the interplay of gravity and the universe's total energy density. It suggests a finite yet unbounded cosmos, a universe of unimaginable beauty and complexity. The McGinty Equation explores a universe shaped like a hyperdonut or three torus. Imagine a donut, its surface curving in on itself to form a closed loop. Now picture that donut as a three-dimensional space. This is the essence of a hyperdonut universe. The MEQ suggests our universe might be rolled up similarly. It allows for a finite universe with no edges, a cosmos woven into a complex, interconnected tapestry. The hyperdonut universe challenges us to expand our imaginations. It reminds us that the cosmos still holds many secrets. The McGinty equation explores hyperspheres and other potential shapes for the universe. What determines the geometry of our existence? The MEQ suggests a balance of fundamental forces shapes the universe. Imagine the universe as a giant soap bubble. Gravity pulls inward, dark energy pushes outward. This cosmic balance shapes the universe's geometry. The MEQ's framework suggests a dynamic, evolving universe. Its shape reflects the interplay of fundamental forces. The McGinty equation extends a hand towards the observable universe, offering testable predictions. It suggests the universe's fractal nature should leave a detectable imprint on the cosmos. Subtle temperature variations in the CMB could reveal the universe's geometry. Detecting these patterns would confirm a finite yet unbounded cosmos. The quest to uncover the universe's hidden geometry extends beyond the cosmic microwave background radiation. The MEQ suggests that the universe's fractal nature should manifest in the distribution of matter on the largest scales. Imagine galaxies clustering in patterns echoing the fractal structure of space-time. Just as tree branches exhibit self-similar patterns, the MEQ proposes galaxies might be similarly arranged. Vast clusters of galaxies could represent the largest branches of this cosmic tree. Smaller clusters and filaments trace out finer fractal details. Deciphering this cosmic code requires sophisticated statistical analysis, comparing observed matter distribution to cosmological models, including the MEQ's fractal framework. By analyzing galaxy clustering patterns, the sizes and shapes of cosmic voids, and the correlations between these structures across vast cosmic distances, cosmologists can search for the telltale signs of a fractal universe. This quest to map the universe's large-scale structure is not merely an exercise in cosmic cartography. It represents a profound attempt to unravel the fundamental laws that govern the evolution of the cosmos, and to test the predictions of our most ambitious theories about the nature of reality itself. The McGinty equation suggests the universe's fractal nature leaves detectable imprints, challenging the idea that infinity is beyond empirical observation. Infinity has long been a concept of pure mathematics and philosophy. The MEQ proposes it as a testable hypothesis. Analyzing cosmic patterns could reveal a finite yet infinite universe. This bridges theoretical physics and observational cosmology. The quest to understand the universe's nature continues with new telescopes and data analysis. The MEQ provides a roadmap with testable predictions. The McGinty equation explores the intersection of quantum mechanics and general relativity, delving into quantum gravity. Space-time is a turbulent sea of quantum fluctuations, a frothing ocean of virtual particles. Imagine the universe's structure as a shimmering, ever-changing tapestry woven from quantum entanglement and gravitational waves. In the MEQ's framework, space-time follows the probabilistic laws of the quantum world. Space-time can exist in multiple configurations, its geometry fluctuating at the smallest scales. These quantum fluctuations create a space-time that is smooth at large scales, but foamy at the Planck length. This quantum nature of space-time impacts our understanding of the universe's origins and evolution. The Big Bang might be an energetic fluctuation within the quantum foam, a cosmic seed for our universe. Space and time might be emergent phenomena from a deeper quantum reality. The MEQ's vision of space-time as a quantum fabric offers solutions to modern physics problems. Quantum structure might prevent space-time from collapsing into a black hole singularity. The MEQ opens new avenues of exploration, hinting at a stranger, more wondrous universe. The McGinty equation explores the role of the observer in shaping reality. Our perspective shapes our perception of the cosmos. Imagine standing in a forest surrounded by towering trees. Your view is limited by the trees. As you move, new perspectives emerge. Similarly, our observable universe is shaped by our position in space-time. Other observers have their own unique perspectives. The MEQ embraces the richness of multiple perspectives. The McGinty equation, through its intricate tapestry of fractal geometry, quantum mechanics, and cosmological principles, offers a compelling resolution to the paradox of an infinite universe. It doesn't shy away from the mind-boggling implications of a cosmos without boundaries, a reality where repetition and variation dance in an eternal cosmic ballet. Instead, it embraces these complexities, weaving them into a framework that is as elegant as it is audacious. The MEQ doesn't pretend to have all the answers, rather it illuminates a path, a new way of thinking about our place in the grand scheme of things. Imagine a universe where the very fabric of space-time is a dynamic fractal structure, constantly unfolding from within, its geometry shaped by the interplay of quantum fluctuations and gravitational waves. It's a universe where our observable bubble, once considered the entirety of existence, becomes a humble oasis within a boundless cosmic desert, a single pixel in an image of infinite resolution. It's a universe where the echoes of our own existence might resonate across vast cosmic distances, where other versions of ourselves might contemplate their place in realities subtly different from our own. The McGinty equation challenges us to abandon our anthropocentric biases, to shed the comforting illusion of a universe created solely for our benefit, and to embrace the humbling yet exhilarating reality of a cosmos far grander and more mysterious than we could have ever imagined. It's a universe that invites us to explore, to question, and to never stop marveling at the intricate beauty and boundless possibilities that lie hidden within its infinite depths. The MEQ is more than just a set of equations. It's a testament to the power of human curiosity, our relentless drive to understand the universe and our place within it. It's a journey without end, a quest for knowledge that transcends the boundaries of our own limited existence, a symphony of discovery that will continue to echo through the corridors of time long after we are gone.